Good day. Welcome back. I'm sure you are learning a lot from the previous sessions and you are familiarizing yourself with how to use different peripherals and different bus, how the connections are, and how the internal registers are connected through. So today we are on day 21. Welcome back. And if you haven't revised, please go back and revise so that you would be able to get yourselves familiar to move further along. We're going to learn today about interfacing an LCD. I just connected all the hardware. I'll show this. Let's see, hardware, it's all connected. So I will get this view out of view. In today's section, this is what you will learn. You're going to learn about what is an LCD and what are all the different types of LCDs available in the market, and you're going to write a simple program and interface that into the LCD. Today we're going to learn about writing the code on a 16 cross 2. That means 16 rows and 2 columns. So that's what it represents, 16 cross 2. Before jumping in, I would like to introduce whom I am representing. I am representing A2DG. It's a startup by Anbukarasu brothers, my brother Alex and myself Arul in 2023. Both of us gathered industry experience over 20 years and we would really like to put it out there so it will all help you to become a better professional. To do that, our mission is to convey our experience and knowledge to at least about 100,000 future professionals through online course. And the main advantage is you can study at your own pace wherever you are. You don't have to go to a face to face class. You can study from wherever you are. Little bit about me. I am Arul P. Anbukarasu. You can call me as Arul or IPA, as persistent as I would like to be to share my knowledge and my experience with you all. I have 20 plus years of experience working in various countries in Australia, Italy, Singapore, and India under all these industries: renewable energy sector in solar and wind conversion, power systems in lead acid batteries, network embedded systems that connects to ATMs, TCRs, and point of sales, and banking automation systems, smart parking operations. And my expertise lies in these three: embedded systems, VLSI, and project management. A small announcement to make: all the videos recorded will be uploaded onto A2DG YouTube channel. In order to be eligible to get a free certificate, you got to watch at least 28 classes. And at the end of each and every class, there will be a attendance link. So please fill that out and send it across to us, and that will count for your attendance for your e-certificate. Unfortunately, if you miss one of the days and if you want to go back, you can't really, because some YouTube regulations, the videos can't live there forever. So it has to be removed after 2 or 3 days. So that's why I strongly recommend you to join one of our internship program, so that will acquire you to learn and get an internship certificate as well. And that's worth a lot compared to other engineers who are not done the same way as you are. And when you land into and work in that first job, your senior engineers will value this certificate and this 30 days experience as a big welcome boost for you. Not only that, you will get your self login to log into a learning management portal. So you can log in and go through each and every day session, and at the end of every session, when you click complete, that will cover your attendance. Not only that, on top of that, you will also get unlimited access to all the course contents, all the PDF materials, the source codes, the reference manual, data sheet, everything you will be getting your hands on. And also the course videos, you could pause, you could go and do something and come back and rewatch it or rewind or recap. Or if you want to go a few sessions back, you can do that because it's all yours to keep. And in case if you got stuck in the middle of this, please do contact our backend support team and they would be able to help you to make you move along in your learning curve. So shall we start to see how you're going to write the code and see the output on the LCD display? I'm excited as you are, so let's get in and learn. LCD. What is LCD? Most of you would be known by now, but I'm just recapping this. LCD is nothing but a liquid crystal display. LCD is a flat panel display or other electronically modulated optical device that uses the light modulation properties to throw the liquid crystals combined with polarizers. So that's why it is a liquid crystal display, because it's light modulating, and with all the crystals in the form you will see the display like this because it has got a backlight. The liquid crystals as such do not emit light directly, instead using a backlight. So this pale green, it's called as a backlight, and are the reflector images in color or monochrome. In monochrome you'll have in color images you also have a different TFT display, and there are few different LCDs available in the market. Today we're going to learn about 16:2 LCD display. There is 16:4, that's 4 columns, and there are other displays that's available. So this is to write your code and view the output in the display in a form of output. So you will be learning that from scratch today. These are all the pin details. So when you buy the LCD, on the top you will see all this ground pin, all these pins on the top, which I'll show you. One sec. Okay, I don't know whether you can read. Okay, these are all the pins that's connected, all these cables, these pins here, it's all connected. So that's the pins we're going to learn now. The first pin is the ground. Functions of the first pin, that's a ground. Then there is the VCC, that's a plus 5 volts, and the VEE is for the contrast of this display, the backlight. So that has to be connected to a port, which is connected to the port, as you can see from this, the blue port. Yeah, so that's connected. And you got 3 control pins. First is the register select. Second is the through the register select you can either send a command or a data. So if it is the register select is 0, then it's a command. If you send 1, then it's a data or a character. And mostly you would use the LCD display to write. So occasionally you would be able to read, but most of the applications we use it for write. So we are also going to use as write. So the second pin, the RW pin, you got to write as 0 to enable as write. And then you got to enable this pin to get the required voltage to get through to the pins. And D0 to D7 is the data lines. So you need, this is a 8-bit LCD. You can also transfer on 4-bit LCD. So that means the first 0, 1, 2, 3 won't be connected in 4-bit, but in 6-bit all the 0 to 7 will be connected. And there is 2 pins at the end, anode pin and a cathode pin. You need to connect anode to the plus 5 volts and the cathode to the ground voltage to get extra backlight. The purpose of the enable switch is to get the high pulse of 3 milliseconds. So that's why you need to connect this enable pin. And D0 to D7 data pins used to send command or data to be displayed. And D7 used in read mode for reading completion of current operations. So D7 can be used also a read mode, but we're going to write to the display. And generally all the LCD comes with hex codes. So these are all some of the hex codes that we will be using. For example, 01, if you write 01 to the LCD, that means you're going to clear the display screen. So you won't see anything, it will be blank. and 02 to return home. Likewise, you got to use some of the hex code, so you will be using 08 display off, cursor off. Likewise, so you're going to use 38. Sometimes it can be 39 in some LCDs, but please check with your LCD provider wherever you buy. Download the data sheet and you will get all the hex codes. Hex code 38 represents, it's a 2 lines, 16 by 2, and it's a 5x7 matrix. It will be in a 5x7 matrix. And these are all for the cursors. Once you, if you write, shift the entire display to the right, and if you write 18, shift the entire display to the left. So it's left, right movement. So you'll be using some of these in our code, which you will learn later. And this is the LCD schematic. So this is how I have wired here, and it's all connected through all the wire. It's all connected through the wire. So all these cables are connected now. So this is how the schematics will look like. The first 3 pins are connected to the port, which is the port. That's the first 3 pins. I'll take this view off. I'll just show here with this, and then the data lines D0 to D7 is connected through these cables, through these D7, and then the anode and cathode, these 2 cables connected anode and cathode, and then the read, select, register, select, read, write, and enable, all these 3 pins. So everything is connected, and it would look like the schematics will look like this. I'll take this view off. I'll also take my view off, sorry. So the view will look like this, the schematics. The plus 5 volts is connected to the VCC. The port adjustment contrast is connected to the VE. VE is connected to adjust the contrast of the LED, the backlight, and also the ground is connected to the ground. Then the register select is connected to another pins, read, write, and enable, and D0 to D7, anode and cathode. So this is how you will see. And you got to interface that with the Nucleo F411RE board. So this is the board connection. So the LCD can be interfaced with this. So the data lines D0 to D7 in LCD is connected to the port C0 to port C7. I did all the connections. And port B, we're going to use 2 registers. So you need to use port C and port B. So port B, you're going to connect all the control lines. Port C, you're going to connect all the data lines. Port B, pin 5 is connected to register select. Port B, pin 6 is connected to read write. Port B, pin 7 is connected to enable to get the 3 millisecond pulse. So in order to use that, first, as you know, you need to enable the peripheral clock. So that means you got to enable port B, that's bit 1 as 1, and port C, bit 2 as 1. So you got to enable these 2. So you got to write 0110 for this, which you will learn later. And then the GPIO mode register. So we're going to use this mode register as the output. So as you know, the port registers, so you got to use output. So 01 is the output mode. And the output data register, you're going to connect all the output data registers. So that's from D0 to D7 that you will learn. D0 to D7 that you will learn that how you're going to connect that, and you will learn that in the program that's coming out. Then also you need to use this BSRR. So this is the bit set or reset register. This is for the read write, register select, and the enable. So you got to choose these 3 pins that I will show you in the program. You got to set that as an enable so you can use those 3 pins. So before going to line by line programming, I will explain how the program we're going to write. So first we're going to declare all the macro definitions. So the PB5, this is how we need to write the PB5 definition. RS, that's in PB5, so you got to write 0 cross 20. That means 0, all first bit, second bit, third bit, fourth bit, fifth bit. The sixth bit you're going to enable as 6, so PB5. So PB5 is this bit, and then PB6 is this bit, PB7 is this bit. So you're going to use all these three to connect PB5, 6, 7 to use these three control lines, RS, RW, enable. So if you go here, so you need to use PB5, PB6, PB7. So you need to use these three pins as 1, 1, 1. And then you need to declare all the prototypes. First you need to send the message in an array format. So this is how you're going to write, and then you got to initialize the GPIOs, and then you got to write functions for LCD command and LCD data, and then you need to write an initialization for the LCD, and then you need to create a delay so that you can see the message coming on and off. Then you got to enable the GPIO initialization. First you need to enable the peripheral clock, so that means GPIO B and C you got to enable. GPIO B and C you got to enable, and then you need to set the output mode register as 5400, which I will explain, and then the bit select you got to set enable and read write and register, so that you can get this value 0 cross 0 0 C, and then you need to set the output mode. So this is for the data lines, and this is for the control lines, port B. This is port C for the data lines D0 to D7, so that value you get 0 0 0 5 5 5. Then you got to write a command for LCD. As I mentioned earlier, if you put register select as 0, that means the LCD is expecting a command. If you set register select as 1, the LCD will expect that data is coming through. So this is the function. This is how you got to write. So you're going to set the BSSRR. So read register select and read register. The 16 times you need to shift left. So this one you need to connect BS15. So you need to shift 15 times to use this port B15. So these bits are write only and can be accessed in Word. So 1 sets the corresponding output data register bit. So that's why you need to set this bit as 1. And then you're going to send the command on the output data register. So you're going to use GPIOC. Then you need to enable the pin BSSR enable, and then you need to send the delay, and then clear the enable by shifting again to 16 to the left. And as I said, LCD data, when you set RS equal to 1, then the LCD would know it's a data coming through. So this is the function you got to write. GPIO B, you need to set this as RS. Then a read write, you need to set this as 0. So you need to shift that to 16 times. And then this time you're going to send the output data register as data, but here output data register as command. So that's the difference, the two. And then the bit set and reset register you need to enable, and delay, give some delay, and then you have to clear the enable. So these three steps will be the same as the command. Enable, delay, and clear the enable. Then you got to initialize the LCD by sending all those hex code values. First you're going to clear the LCD, and then you need to set the 16 cross 2, so you got to send 0 cross 38, and then set bit data mode. Then you got to write 0 cross 0 C to the LCD, and then you got to write 0 cross 0 6, move the cursor to the right. So every time data comes through one bit, so the cursor will jump to the right position. So that's what 0 cross 0 6 is. Then you're going to clear the screen by sending 0 cross 0 1. That will wipe off all the message and will wait for the new message. Then give some delay, and then turn the display on by giving 0 cross 80. Then give some delay. Then you are checking whether the message has come through or not. So you got to write a simple while loop and then connect to the LCD data function, check with the message of I and increment one after the other, I plus plus, then give some delay and then close. So this is the LCD initialization, which you will learn shortly in the program. And then this is the simple LCD delay. You got to write a function, then you got to give delay and delay minus minus. So since we are using a 16-bit, the count comes to I less than 3195. Also, because it's a 16 by 2, so it's a 8-bit data line. So if you calculate, then it will come as 3195. That's why this value 3195 is there. Just checking in case I missed anything to tell. Just one sec. Also, this line is used for, because we are using 16 megahertz to get 1 millisecond. If you do all the calculation for 8-bit data lines for 1 millisecond generation, you get the value 3195. And you got to write a main program. As you know, you need to call the initialization in there. And that's also, let's get into the IDE and learn from line 1. So I'll see you out there. Go and enjoy that short break. I'll see you in a couple of minutes. So see you then. See you.